Okay, so we talked about the projection of B onto the vector A. Picture of that was something like, here's B, here's A, the projection is this vector here. We came up finally with this formula. The projection of B in the direction of A can be written like that. Now, we're not going to spend too much time on this cross product because we don't really need it. But just let's go through it quickly. The cross product of two vectors, she calls it an honest product because if you recall, the dot product gave us a scalar. So somehow that's kind of less good in some way. Or anyway, here the cross product is not going to give us a scalar, it's going to give us a vector. So you're going to take A cross B, that's how we're going to write it, and we're going to get a new vector. So if this is the vector A and this is the vector B, then the cross product is going to be another vector, and it's going to be perpendicular to this plane that A and B is in. But then even if it's perpendicular, we have two things that we don't. Just saying it's perpendicular doesn't determine what vector it is. There are many perpendicular vectors. For example, you could have one that points down, you could have one that points up, and then even if you had one that points up, you can have many different lengths, an infinite number of lengths. So which vector is it? So first of all, which direction does it point? Well, in this case, if you're doing A cross B, by the way, that's not the same as B cross A. So if you're doing A cross B, you use if you want to know the direction that it is going to be, you take your right hand. You have to do this with your right hand. If you do it with your left hand, you get the opposite direction. So you go from A, you point your fingers in the direction of A, so you stretch out your hand. Now the hand is curled, but you stretch it out in the direction of A and then rotate it towards B. And then whatever direction your thumb is in is the direction of the cross product. But then okay, so now we know the direction, but what's the length? Well, what we're asking then is we're asking what's the magnitude of it, but we know we have something for magnitude, and that is the norm. So that's this, the norm. So the norm turns out to be equal to this. In fact, that is the definition of the length, because this is the definition. So the definition of the norm, or is the norm of the first one times the norm of the second one times the sine of the angle between them. Now that's different than before. I mean, when we showed an expression. Remember this expression we had: A dot B is the length of A times the length of B times the cosine of the angle. So when we're dealing with dot product, cosine shows up in certain places, like here, in terms of its what it is. But when we're dealing with cross product, sine shows up, as we can see in the definition. Okay, so the angle that they're talking about, sine of theta, is the angle between A and B. So what does that mean? If remember that the sine, when is the sine biggest? The sine is biggest when you have a 90-degree angle, or if it's a 270-degree angle. The sine is the y coordinate, so it's largest at 90 degrees, let's say. So when is this cross product going to be largest? It's going to be largest when A and B are perpendicular. Okay, I mean, given a particular length A and a particular length B, then if you take those two vectors and you want to take their cross product, the cross product will be largest when the two vectors are perpendicular. Okay, you can see that here. So as an example, we can figure out the cross product of I and J. Well, it turns out that the cross product of I and j is k. Well, it's not too surprising that it's in the direction of k. Well, it could have been the opposite direction, but if you think about the rule that we just had with the right-hand rule, go from here to here, you're going to get k. Now, by the way, if we wrote j cross I, then what? Then if you did j first and you use your right hand, you're going to be pointing down when you go from j to I and you use your right hand. So we can also see that the direction of j cross I is going to be minus k. But anyway, for I cross j, we know the direction is going to be k. And then what's the magnitude? So how big is I cross j? It's going to be the magnitude of I, which is 1, times the magnitude of j, which is 1, and the sine of the angle between them, which is 1. So it's going to be 1. So in other words, it's going to be exactly k, because the magnitude is 1 and the direction is k. And we can do the other ones, jk and ki. So we just did I, j, and we got k. If you do jk, you're going to get I, and so on. And if you go the other way, we just said what's going to happen. So it's pretty clear that A cross B is not equal to B cross A because they point in opposite directions. But I think we can sort of see that A cross B is equal to minus B cross A because that's going to switch the direction when you put the minus there. Okay, there are some other properties here. So by the way, this is not commutative, means can't just switch the order, but they have some name for this. They call it anti-commutative because it's almost the same as commutative, but you have minus. Remember that for matrices, if you have a matrix A and B, remember that would be like a capital A and a capital B. We haven't talked about matrices in this book, but we did talk about them before. And A, B is not equal to BA. There's no even semblance of commutativity. It's just not true. AB is not equal to BA, not all the time. Of course, sometimes it might be, but generally speaking, it's not true. Okay, here's another example. Suppose we want to do the cross product of these. So we can rewrite these like this, because why? Sorry, I skipped ahead. First, we have to do this, that A cross B is going to be equal to this big mess here. But, sorry, didn't stop there. But A cross B is going to be equal to this. Okay, so we have to go through all the algebra of this. You have to sort of collect terms and use distributivity. So you use these properties here, and they explain how. So, for example, A cross B plus C, you can rewrite it as A cross B plus A cross C, and we use that in here, and some of the other properties. And finally, you can read through it. We get to here. What in the world does this mean? So how can we sort of remember this? Because it looks like a mess. So look at that A. Look at how we write A, how we're going to write A. A1, I, A2, J, A3. So we're going to use A's for the A vector. We're going to use A sub 1, A sub 2, A sub 3. And for the B's, we're using B sub 1, B sub 2, B sub 3. Now let's see what we've got down there. So for I, one last thing to notice. So the coordinates, the coefficient for I here is A1 and here is B1. Okay, so just remember that when we're doing I, the coefficients are sub 1 and sub 1. Coefficients for J are sub 2 and sub 2. Coefficients for K are sub 3 and sub 3, right? A sub 3 and B sub 3. Okay, with that, we can say, okay, what is I? What is the coefficient for I in the product? So there's no ones in here. So that's one way, that's part of how you can remember this. So the coefficient of I has a 1, a sub 1, or b sub 1, but this thing has none of those, no sub 1s. This one has no sub 2s, and this one has no sub 3s. Okay, that's part of the pattern identified. And then what else is going on? It turns out that we have A2B3 minus A3B2. So these are, we start out with 2 and 3, and then we still have 2 and 3, but here the A has the 3 and the B has the 2. Okay, it's going to be the same thing here. We're going to have 3 and 1, and 1 and 3. Okay, so anyway, I guess that helps to remember this. So using this, we can say, now we can say, how do we do this? So that we can say, what's the I coordinate? So what's the I coefficient? And it's going to be A2, B2. So we take that. There's that A2 is 3. B3 is IJ is 0. IJK is 2. And so on. You can figure it out. And we end up with this. Oh, okay. Now we've already done matrices. And I think we've already done determinants. But let's read through this a bit here just to make sure that we have that they're doing it, they're using the same language that we used. So here we have 1, 2, 3 matrices, and we're going to define the product of the two, of a pair of them. Okay, and we know that this is a 2 by 3 and this is a 3 by 2. So 2 by 3 and 3 by 2, we're allowed to multiply those together. We've talked about that already. So here's the product. Let A be 2 by 2 or 3 by 3. Oh, sorry. First we're going to define the determinant. Suppose we have a 2 by 2 or a 3 by 3. We're going to denote the determinant using either this notation or this notation. And so here's the determinant of this. We can also write it like this. And we said that it's AD minus BC. So that's what we have here. And here, we said that you have to do it like this. You have to say, here's A, and then take this stuff here and find its determinant. So this is A, so you don't do anything here. You don't include anything here or here. So you just include EF, HI. Then for this one, this is B. You don't include anything here or here, so you're just left with DJ and FI, DG and FI. And then C, you only include this stuff, so it's DG and EH. Okay, and then now we know how to do this, this, and this because we just explained that this is how you do it. So now we can work this out and we can get an answer, and I guess this is what you get if you do that. And then they say there's another way to think about this, and that is, we already know the formulas here, but they say you can also get the same answer by doing this. You take the diagonals. So you take, we said it was AD minus this one. So that's what we get here. In this case, what you have to do is you want to be able to write the diagonal here, a diagonal through here, so you're going to need an extra column here to finish this one off. And then a diagonal down here means you're going to need yet another column to finish this one off. So what do you put in this column? You just repeat this one over here and this one over here. Okay, now you take these diagonals. So you get AEI minus GEC. Well, is that what we've got? AEI minus matrices. Yep.